Now I'm going to talk to you about arithmetic sequences. These are sequences that have a definite pattern. You will be going, the first obvious one is when we count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have a difference of 1 between each of those terms. We are going in an order. We don't jump out of order. We don't put 7 before 6. And there's a term associated with each one of those numbers. Let's just start off with an example of an arithmetic sequence. I'm going to do 2, then 5, 8, 11, 14, 17. What's my pattern? I start with 2, and then I get to 5. Looks like I'm adding 3. Let's check. 5 plus 3 is 8. Yep, 8 plus 3 is 11. 11 plus 3 is 14, 17. My next one is going to be 20. So in this case, my distance or difference between the two, which we call D, is 3. I'm going to write that. D is 3. It's always 3 apart. 3 apart. If I want to know so my first term is 2. If I want to know what my second term is, it's going to be 2 plus 3. If I want to know what my third term is, it's going to be my second term, A2, plus 3. But A2, I should have written A1 here. But A2 is going to be A1 plus 3 plus this 3, so it becomes A1 plus 2 times 3. A4 is going to be, in this pattern, A1 plus 3 times 3. And so we can come down and we can say, all right, our nth term is going to be our first term plus n minus 1 times whatever our difference is. In this case, it's 3. So if I say, what's my sixth term? A6. Well, of course I could write it in 5. Let's do something like my 17th term. Yes, I could write out 17 terms, but I don't need to now because I have this nice little handy formula that I created. It's going to be my first term plus 17 minus 1 times my difference, which is 3. Well, my first term was 2, so my 17th term is going to be 2 plus 16 times 3. 17 minus 1 is 16. 16 times 3 is 48. 2 plus 48 is 50. If you write out 17 of these, by the time you get to your 17th term, you're going to be writing a 50. Don't think the D has to be a positive number. It could be negative. Suppose my pattern is 3, negative 2, negative 7, negative 12, negative 17, on and on and on. My first term is 3. My second term is 3, looks like a minus 5. My third term is 3 minus 5 minus another 5. 3 minus 5 is negative 2. Negative 2 minus 5 is negative 7. So we can write our general formula then as a1 is equal to our nth term plus n minus 1 times a negative 5. And let's see if that checks out. Oops. Wrote these backwards. Pardon me. A sub n, a sub 1. In this case, let's see, 1, 2, 3, 4, 5. Let's do a couple more. Minus 22, minus 27. So now I've got 7 terms. Let's look and see, what is my 7th term? Well, it's equal to my first term, which is 3, plus 7 minus 1 times negative 5, which is 3 plus 6 times negative 5, 3 plus, which is negative 30, 3 plus negative 30 is indeed negative 27, which is what I get that way. So you understand that all I'm doing with an arithmetic sequence is I constantly am adding or subtracting the same amount from each term as I progress along. If I asked you to count up by odd numbers, you go 1, 3, 5, 7. You're adding 2 to each one of those numbers when you move on. If I asked you for even numbers, you'd still be adding 2, 2, 4, 6, 8, but you're starting with a different first term. That's the difference.